Here in this question, we're given the impulse response of an LTI system. And we're told the input is a step function. And we're asked to find the output y of t. Now normally, you could find the output by simply taking the input and convolving it with the impulse response. That's how we would normally do it. But in this particular question, we're told that the input is a step function. So the output, by definition, is something that we call the step response. So what we're actually after is the step response. And we can get the step response directly from the impulse response. So rather than carry out a convolution, which is easy enough, an even easier way is to find the step response, s of t, which is simply the integral of h of t. But I'll use a different variable here for integration. So we simply need to take this function and integrate it. So I'll replace h of alpha with 4e to the minus 2. Let's call it alpha. U of alpha, d alpha. Now remember, whenever you see a unit step in an integration, we can use that and just simply replace it by its equivalent value, 1, and then replace the relevant limit. So in this case, the limit would be 0, because our unit step it starts at 0. So this is my u of alpha. So I might as well simply replace the unit step with 1 and change my lower limit. So now it's a much easier question. I'm simply integrating an exponential. And it's a really easy integration. It's simply minus 4 over 2 e to the minus 2 alpha from 0 to t. And 4 over 2 is 2. And if I get rid of the minus sign by reversing the limits, I have e to the power 0 is 1. And e to the minus 2 t. And then I multiply by u of t. That u of t there is simply in recognition of the fact that t here has to be greater than 0. So t is greater than 0. For this integration to be valid and to be non-zero, t has to be positive. So what I've just found here is the step response, s of t. So that is my answer. It's 1 minus e to the minus 2t u of t. And if the question had asked for a particular value of t, I'd simply put that value there, and that will give me my output. Alternatively, we could have carried out a convolution, or we could have found the transfer function and multiplied in the S domain. But this now here is my final answer.